13.2 seconds. I'm assuming that's a rounding error.
Maybe not. We'll see. Let's take a look at the top here. That, of course, is 42 degrees. We're going to take the 0.389 times 60, right? So 0.389 times 60. 23 minutes. So I'm going to take off the 23 times 60, 20.4. So 42 degrees, 23 minutes, 20.4 seconds. Down here, you're thinking rounding errors. It's very, very possible. Usually I go to 4 decimal places when I do these out, just because that minimizes the rounding errors, but let's take a peek. So we're going to start with the 16 here and divide by 60, which turns that now into minutes. So we're going to add that to the 38. We're going to add the 38 to that. So 38.266666666. Now we're going to take that and divide it by 60 to turn it into degrees. And then we're going to add the 19 degrees to that. 19.6377. 78 if around, in decimal degrees. Now, looking at your calculators. You guys have Sharps, don't you?
No, I have Casio.
This is Casio and you got TI. Depending on your calculator, you might have a key that looks like that.
Oh, really? One.
Should be up above the number pad. Might be an angle key, depending on your calculator. On this one, where is it? Oh, shoot, this one's a little different. Math.
Different modes.
There it is. So what you would do is, let's say you were going to enter in your calculator 42. Oh, let's do the 19, 38, 16. You type in 19, hit math. DMS, select degrees. 38, hit math. DMS, select minutes. 16, math. DMS, select seconds. Then just hit equals, it changes it to decimal degrees. If you want to go the other direction, with it in decimal degrees, you hit math, go over to DMS, arrow down, option 4, 5, there, 6 should be 2 DMS. Select it, you gotta hit it twice, changes it back to degrees, minutes, seconds.
I give up. There's a calculator for everything.
So, you know how to do it on the calculator. Now, the only thing is, like, one of the next steps we're going to do is we're going to do operations with degrees, minutes, seconds. You can use that key to enter it in, but it's always going to give you your answer. Usually it gives you the answer in decimal degrees, so you just have to use that conversion to get it back to degrees, minutes, seconds.
You enter each one separately.
Yep.
You enter the first number.
19 hit the key, 38 hit the key, 16 hit the key.
So it goes
19 hit math.
Yeah, no, 19 degrees, 38 minutes, 16.08 seconds.
Yeah, it's to round off error. Because it was, 0.777, you round it to 0.778. So, let's take a peek at something like this. Not as tough as it looks. Just like any operations with any of our other measurements, we're going to do 43 plus 38 is 81, right? So that's going to be 1 minute and 21 seconds. So keep the 21, carry the 1. 19 and 51 is 70, which is 1 degree, 10 minutes. So carry the 1, keep the 10. That's 28, 34, 44 degrees. What do you think? Doable?
Actually, it's easier that way.
And actually, you can enter it in your calculator if you want to. It'll work. Yep. So here, I'm going to give you a problem to do, and I want you to try it by hand and with the calculator. See if you get the same answer.
Sometimes they'll get confused and go round after the 12.
True. So give that one a shot quick. Do it both ways. Let's take a peek. It's not 34 seconds, no. This is 84, right? So that's going to be 24. Carry the 1. 38, that's 80, so that's going to be 20. Carry the 1. And that is 58. So the calculator was right and you were wrong?
Yeah.
Okay, well.
I got 20 and then, yeah, 24 seconds. Yeah.
Okay.
Calculator's right.
Well, did you see what you did wrong?
30 minutes?
I just,
You only took 50 away instead of 60. When you you had 84 there, you just did, when you carried, you subtracted it wrong when you did it.
I
Is
did
all.
50. Wow. Because I'm thinking, don't use 12. Oh, man. Don't be careful.
Only if you can get it in right. That's the first part.
So we go to subtract, of course. 37 minus 43 doesn't work, so we're going to borrow. This is 17. What did we borrow, though? 60, so this is 97. This is going to be 54. 17 minus 32, again, we're going to borrow. This is now 41, and this is 77, right? We added 60. 77 minus 32 is 45. 41 minus 19 and is 22. So now for you guys to try. $37 degrees, 19 or 23 minutes, 19 seconds. Minus 28 degrees, 42 minutes, 27 seconds. See what you come up with both ways, hand and calculator.
Yeah, he's got
So,
full of it today, isn't he?
19 minus 27, we're going to borrow. This is 23, 79, or 22, sorry, and 79. So that is, what, 52? 22, this is going to be 36, and this is going to be 90, or no, 82. Wow, I can't borrow worth a crap today. 82 minus 42 is 40. 36 minus 28 is 8. 8 degrees, 40 minutes, 52 seconds. Good deal. Now let's make it a little more difficult.
So,
Multiply it in these things?
That's where we're going.
and then divide, and then we're going to split rid of, then we just split it.
You're getting a little ambitious there.
And then we're just going to have a whiskey.
I like your plan. 53 times 4. 212, right? Now we can take 60 out of 212 3 times, which would be 180. Leaving us with 32 seconds. 4 times 34 is 136, right? Plus 3 is 139. We can take 60 out of that twice, which would be 120, leaving us with 19. 4 times 24 is 96, plus 2 is 98. 98 degrees, 12 minutes, 32 seconds.
Right? So 12.
19
minutes, yeah. 98 degrees, 19 minutes, 32 seconds.
Now, if you added two big angles together and came up with more than 360, how do you...
We'll get to that. We'll get to that later. You can reflect it as that. It depends on what you're doing. If it's a rotation, then you can leave it as something bigger than 360. If it's an absolute geometric angle, then there's things we'll talk about. Give that one a shot. Again, by hand and
159,
159, 220. So what is that? There's a 240, 242. Yep. So that's 6. That's 6, 4. 159. Yep, you are correct. 159, 220. This looking like Greek tea over there, Dustin? Yeah. The key is it's 60 minutes in a degree, 60 seconds in a minute. So let's say we divide this into 6 equal pieces. 6 goes into 34 5 times. That's 5 degrees. 5 times 6 is 30. So that's 4 degrees. Now, just like we did with the measurements, we're going to convert that. 4 times 60 is 240. Bring down the 27 is 267. Now we're going to divide that by 6, which is 44, which is going to be 264, right? Bring down the 3. Before we bring down the 3, or before we bring down the 12, turn the 3 into 180. Bring down the 12 is 192. Divided by 6 is 32. Not so bad? Well then, here you go. Let's do 45 degrees, 3 minutes, and 32 seconds. Is that going to work? I better be careful. Let's do 48 seconds. We'll divide by 12. See what you come up with. Calculator. So we're going to get 3. That'd be 36, right? So that's going to be 9, which is going to be 540. So 543 divided by 12 is 45, right? Which is 540. With 3, so that's 180. Bring down the 48 is 128. Or 228, thank you. Divided by 12 is 19.
What if that last one comes out is not a
You can go 1 decimal place on the seconds.
one?
1 decimal place. But like I said yesterday, that realistically, I've never seen any place in this area that goes below 5 minutes for their precision on their degrees or for their angles. So I mean, I've never seen a place around here that even goes down to the second. So the decimal seconds really are, like I said, you get into optics. You have to use lasers basically to measure down that tight. You guys all know how a protractor works, right? It may have been a while. Protractor looks like this. Somewhere down here you got a 0 point. Usually a dotted line or whatever. It goes off to the side like that. Sometimes it's right on the very bottom. Yep. And when you set up your angles, you got to put one side of the angle on that line, and the other side, the vertex has to be at that little crosshairs. Then the other side tells you the size of the angle. Whether it's on this side or it might be on this side here, doesn't matter, right? And of course, 90 degrees is up here. It's the numbering in here that's a little weird. Pretend those are evenly spaced. Let's say you're looking at this. This is labeled 40. Like that. How do I know which one to use? This says both 50 and 130 degrees. Well, 2 things. If my starting side is on this side, then I use the scale that starts at 0 here. Also, the easier way, the way I remember it, is this acute or obtuse? Acute. It's smaller than 90 degrees. Which number do I have to use? The one smaller than 90 degrees. So this is going to be like 47 or 48 degrees between 40 and 50, not between 130 and 140. Make sense? So the same here. This is going to be like 10, 20, 30. But this might also be 170, 160, 150. This is an acute angle. We're going to use the smaller numbers. Well, since we are measuring to the nearest minute, something you guys may end up with is something called the universal bevel protractor. Universal bevel protractor actually has one edge goes on the angle and one edge goes on the other side of the angle. So you can measure angles on physical objects, and it comes up to a scale here. And what you'll get is there's a scale here that has a 0 on it, and you measure the main scale at that 0. So let's say this is like 40 degrees. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 50. Like that. So the way this protractor is set up is usually set up like this. Now there might be little marks in between them for the 5 minutes, but the one I've got set up here, I've got labeled 15, 30, 45. Those are minutes. It might have, like I said, it might have marks in between them for the 5, 10, and the 20, 25. I'm going to leave those off. Some of them have them, some of them don't. If you get down to 15 minutes, that's down to 1/4 of a degree. That's getting relatively precise. I mean, there are stuff you guys do that need to be more precise than that. But so the first thing we need to find is what direction the main scale is reading. The main scale is increasing in that direction, correct? Okay. That's going to tell us that we're going to read the vernier. This is a vernier scale in that same direction. The 0 on the vernier scale is between what two markings up here? Well, this is 45. That's 46 and 47. So it's between 46 and 47, which means we're going to use the 46 degrees. Now, which one lines up here? It's the 30. So that's 46 degrees, 30 minutes. Does that make sense? All right. Well, we are slightly out of time. So what I'm going to have you guys do, by the way, you remember what complementary and supplementary mean, right? Complementary means to add to 90, supplementary means to add 180. So if I give you an angle like 41 degrees, 37 minutes, 52 seconds, and I ask you to find the complement, what are you going to do? Yeah, 90 degrees, 0 minutes, 0 seconds, and you're going to subtract that, which is going to give you 47 degrees, 22 minutes, and 8 seconds. Okay, so in your packet, I gave you 266, 1 through 75, the odds yesterday. But I went over the multiplication and division today, so those might be a little easier for you. Also, check in that packet. Is page 275 in that packet? Anybody have that packet with? Does it go up to at least 275? What page does it end on? Yep. I gave you a new one yesterday. Oh, you're still in the spur gear? I believe it goes up to at least 275.
284.
Perfect. On page 275, there's a few of them there that deal with reading the universal bevel protractor. So make sure you do those. Any questions?